Hello everyone, I wish you a very warm welcome to this XDF two-stroke engines webinar on operational efficiency and future developments. We do have a really good agenda for you with 3 very interesting presentations followed by questions and answers. Our presenters are all subject matter experts in their fields, and I'm very delighted to introduce them to you. First, we have Carmelo Cartelemi, who's Head of Global Sales with WinGD. Carmelo has a PhD in marine engineering and has worked with Wärtsilä and WinGD in various positions over more than 10 years. Carmelo will present XDF two-stroke engines and future developments. Hello, Carmelo. Then we have Adrian Siegfried. Adrian is General Manager, Customer Support, also with WinGD, formerly Wärtsilä, since 2002. Adrian spent 13 years in South Korea as an active member of the service department from its beginning. Later, he spent time in the new build sector, running the operations team. Adrian now leads the newly created customer support group, WinGD's interface to key customers, ship owner operators, and to engine builders. Adrian will present operational service experiences with the XDF, and he will expand a bit about the cooperation between Wärtsilä and WinGD. Hello, Adrian. We also have Jürgen Nayer, who is General Manager, Agreement Sales, Middle East and Asia in Wärtsilä Marine's Performance Services team. Jürgen has been with Wärtsilä for more than 20 years, the last 5 of which he has been developing life cycle agreements, which he will present to us today. He will explain how performance can be improved with an agreement, and importantly, he will share with us real-world customer feedback, which resonates very strongly. I'm sure you'll agree. Hello, Jürgen. Concerning the practicalities, as mentioned, Q&A will follow the 3 presentations. To ask a question, please simply use the widget shown on your screen. When asking a question, you may also name the speaker to which you'd like to put your question, and we will answer as many as time permits, but we will follow up outside of the webinar any questions that go unanswered. I can point out that there will be a couple of audience polls along the way, so please look out for those and respond as appropriate. Your responses will be helpful to us later. Now I'm delighted to turn it over to Carmelo to open the discussion on the XDF. Carmelo, the floor is yours.
Thank you, Jeremy. Good afternoon, good morning, everybody. Very happy to be here today. I present today the XDF technology and future development. WinGD mission is to serve the shipping industry with the highest possible technology and reduce the emission. This is our mission. So let's get started. So the XDF technology started 10 years ago. Here in Winterthur, we had the first concept together with Wärtsilä. At that time, WinGD was part of Wärtsilä. Then we had the first test engine that still we have in Trieste, one of our test facility. Then was the first commercial installation, and started an escalation of market success. To make this long story short, we have a 400 engine XDF in service and in order. We are the standard propulsion system for LNG carrier. Also, when it comes to LNG powered ships, we power the first Aframax, the shuttle tanker, VLCC, ultra-large container vessel. So we are present in all segments. But what is important and remarkable over the last 10 years is the technology development. XDF is the first low-speed, low-pressure dual fuel engine in the market. We accumulated more than 1 million running hours. Last year, we launched the XDF 2.0 because the goal is to reduce the emission. We do in 2 ways. One is to increase the efficiency of the engine, so reducing the gas and the fuel consumption, and reduce the maintenance sleep. This year, 2021, we upgraded the XDF 2.0 with ISER technology, using the same hardware that we use for reduce the maintenance sleep and increase the efficiency, also in a diesel mode for each tier 3 to reduce the capex. A look at the technology, at the concept of XDF. The secret is the low pressure. Low pressure means that we inject gas in the combustion chamber at 13 bar. These have several benefits. The first benefit is the gas supply system. 13 bar is a gas supply system that is relatively economically convenient. And also from technological point of view, using the Otto cycle, we have a very low NOx, much lower than the Tier 3 limits. And then the efficiency is at a good level. So overall, the XDF is the best CapEx, OpEx product for LNG powered ships. Of course, we need to increase the efficiency and reduce the methane slip. That is the, let's say, the point that needs to be improved for the Otto cycle. There is a lot of margin of improvement, and that's what we are doing, what we have done, what we have solved with the XDF 2.0. But let's have a first look of what the performance engineer wants to optimize an Otto cycle engine is to enlarge the operating window. Let me explain better. We have the gas reactivities, that is an index of the lambda ratio, air-fuel ratio. And we have an operating window because we want to increase the BMP as much as possible, but there is some physical limits due to the self-ignition or to the knocking. So the gas reactivity or lambda control is very critical. So we want to enlarge as far as possible the operating window. And that's why we have come out with a solution to propose the ISER technology. ISER technology is intelligent control over the exhaust recycling. We're recycling exhaust gas. We do this after turbo, so it's a low pressure recirculation. Part of the exhaust gas will be cooled and then will be reintroduced again in the combustion chamber after the turbo, so it's a low pressure system. Exhaust gas after the turbo are basically CO2 for the gas combustion. The CO2 is, from the combustion point of view, an inert gas that facilitated the combustion. In which way? I will show in this slide. Introducing the CO2 in the combustion chamber, we have the effect to reduce the firing pressure. More we recirculate, more we reduce the firing pressure, and then also we can adjust the pilot injection. So you can see we give to our performance engineer another dimension to optimize the engine. Put in simple word, what we can do is to increasing the firing pressure, increasing the compression ratio, and also changing the adjusting time. In this way, what we achieve is the reducing of gas consumption, reducing the liquid fuel consumption in diesel mode, and most important, we reduce the methane slip. We reduce the methane slip because of two important effects. One is the combustion is more stable, and then we have less unburnt. Second, because of the recirculation, so we reduce between 40% up to 50% of methane slip. That is remarkable, because when I remember 10 years ago, the standard of methane slip of an industry was 6 gram kilowatt hour. Today, with XDF 2.0, we are below 1 gram. We are 0.8 gram kilowatt hour. So that is the message that methane slip is a technological problem, and there are solutions to solve it. So that is a very important step forward. But let's look a little bit at the reduction of gas consumption. That is also very important in terms of CO2 emission. So in gas mode, the reduction of gas is between 6.4 to 4.4 gram kilowatt hour, depending on the load. In diesel mode, ISER is bypassed for Tier 2 operation, but still the reduction of fuel consumption is applicable because of the increasing compression ratio. We are between minus 8 gram to minus 5.7 gram kilowatt hour. Again, what is the focus for winter to gas and diesel in the recent years is to reduce the emission. XDF was designed to reduce the emission. If you can see on the left side, we have XDF, let's say 1.0, and the right, the 2.0. The difference between these two emission profile is the methane slip, and so the CO2 equivalent that we reduced between 4 to 5 points. So compared to the traditional diesel engine, we are between 20-25% less CO2 emission. This is the first step for decarbonization, where WinGD is fully committed. Of course, if we see the global picture of reduced, this is not only CO2 that is impacting on greenhouse gas, but it's also all the emissions that impact the quality of air, like NOx, SOx, and PM, where basically we reduce it to very low level. For instance, NOx, we are much below the tier 3 limits always, also when the ships are running in non-ECA area, and that's without the help of a post-treatment system, just because the Otto cycle, the same SOx, and also the PMs is very low. Even though these emissions are not really regulated outside ECA, and XDF emit very low level of NOx, SOx, and PM. So that means that overall, the emission, as an engineer, if I look at this emission profile, XDF is one of the most competitive engines in the market when it comes to emission. So just let's have a look to the ISR technology. How look like on the installation is an off-engine solution that need to be installed close to the engine. We worked with the shipyard, the major shipyard, to have this accommodated in the engine room. You see this hardware is used in gas mode for reducing methane slip and the increase in the efficiency, but also recently this year, as I mentioned before, is used also in the diesel mode to reach the tier 3 level, and that's also is a good compromise to reduce the capex, because with the same hardware we reduce also the NOx level. So thank you very much, and just the concluding word is XDF for winter to gas and diesel is the initial step to the decarbonization. We are also considered alternative fuel to be burned in the same engine platform. So hand over to you, Jeremy.
Super, thank you very much, Carmelo. That was a nice introduction to our session today, and really impressive to see in particular, the emissions reductions that you have brought into being. I am seeing, just a quick message to our audience, I am seeing a couple of hands raised. If I could kindly encourage you to use the questions widget to ask questions, type your questions into the questions box, and we will take as many as time permits. But that does bring us to our first poll, audience poll. So we would ask you to kindly read this and select one of these responses, and we will take away your answers with us. They will be interesting to us. But if I can help here by reading, a future-proof main engine should be able to operate with the following fuels. Please select one of the following: LNG, bio-LNG, biofuel, ammonia, methanol, ethanol, or hydrogen. If I could give you a moment to respond to that poll. Super, I see we've got a lot of results, a lot of votes in. Carmelo, perhaps I could turn to you to kindly interpret those findings from us in this short space of time that you've had.
Yeah, thank you. Very interesting to see this result, very useful also for us. As I said before, we are fully committed to find alternative fuel to decarbonize. Very interesting to see that ammonia and LNG are considered like the future fuel. Also hydrogenum, that is very interesting and also useful for us. Thank you very much.
Thank you, Carmelo, and thank you, audience, for your votes. That does bring us time to hand over to Adrian. Adrian, the floor is yours.
Well then, thank you, Jeremy. Good day, ladies and gentlemen. It's a pleasure to be here, and I will tell you a little bit something about the service experience which we do have on our ever-growing XDF fleet, and also I will have the pleasure to give you a brief outlook in the future on a recently announced upgrade of the very popular X72DF engine. So, a quick look into the engine shop. We do have, let's say, a huge variety of XDF engines which pass their factory acceptance tests or respectively are under R&D testing. Meanwhile, the picture is very complete. We do have the first 40DF engine which passed its FAT in China just actually last month, and the very first X82DF engine is undergoing R&D testing also in China, and with these engines we have now the full portfolio from 40 up to 92DF engines complete. We also have a number of more than 200 engines which passed their factory acceptance tests on the former popular bores, the 50, 52, 62 and 72, including 92DF engines. Looking at the shipyards, the picture is equally impressive. As of today, we have in fact more than 100 DF engines in operation, which has surpassed more than 1 million accumulated running hours. Longest running ship is more than 26,000 running hours. And we have actually a huge variety here on vessel types, which are using our XDF engines. Some of you may remember it started with a turn tank series back in time, product carriers operating in the Baltic Seas. But soon thereafter, then LNG carriers started taking over, tankers of various sizes, ice class tankers. And more recently now we also have had the first bulk carrier, shuttle tankers, and of course the ultra large container carriers from CMA CGM, which entered operation powered by XDF. Now we move over to some service experience update. First topic here is piston running. Piston running, of course, is always an interesting topic on two-stroke engines, and on our XDF fleet, in particular on the mid-bore DF, we did have a few learnings, and they are outlined here. As a matter of fact, some cylinder liners were lost in the second half of 2019 and early 2020, and we were able to trace back the incidents there to, first of all, water ingress in the cylinder liner through the pre-chamber. On the 72DF in particular, we did have a design, let's say, flaw, and this was rectified by, let's say, adopting the design to the same dimensions as we have on the other engines on the 50, 52 and 62DFs. So this is resolved. Service letter was also released in this respect, and the whole fleet upgraded. The second topic is actually that the cylinder lubricants from the first generation, simply taken over from diesel applications, were not suitable for the Otto cycle combustion, resulted in deposits in the ring grooves, sticking piston rings, and thereafter then, let's say, arising piston running troubles as well. Also associated partly with the cylinder lubricants thermal load, we have seen that in Otto cycle combustion, the thermal load on the combustion chamber components is higher, in particular on the cylinder liner running surface, and this one brings some additional challenges to the cylinder oil. We have had some improvements on the jacket cooling water system, which needed to be implemented to control the cooling water temperature, respectively the liner wall temperatures. Today we can state that the piston running is back on stable levels, as we have it at the beginning, and this is of course very nice to see. Furthermore, we also implemented the learnings from these, let's say, mid-bore DF engine topics also to other bores in the fleet. Some words about the jacket cooling water system, which was, let's say, creating some challenges from the very beginning. We realized that venting is important in the alignment of the water guide jacket. If that one is not properly aligned, we can actually face the issue of internal bypassing in the cooling circuit. This we have to avoid. At some point of time, we realized it is important to get, if there is, let's say, an accumulation of air bubbles or gases in the cooling circuit, to get rid of them by air separators. They became standard again on the new builds from 2019 onwards. And then more recently, we went back actually to the so-called Uniflow design for the new builds, but also as offering as retrofit for ships in operation, where the whole water flow is led through the liner. So we move away from the bypass solution of the first generation back to Uniflow, having seen the advantages of this system. Now something about the more recent engines which came into operation. Here this is about the X52DF. We have the first engines now in service since roughly 1 year. This is the first XDF engine which is actually featuring a 2-ring piston design, and we have seen excellent running conditions, not only on a piston or let's say combustion components, but also generally. The engine was attended for a major inspection last month, and we have seen that everything looks, let's say, as good as it could be after 1 year in operation. Not on this particular vessel, but more later delivered X52DF, we also have the first IGPR applied, and this system proves to work very well on this car carrier. Moving over to the biggest board, the X92DF, where meantime 6 vessels are in operation. The very first ship of this series of 23,000 TEU container vessels, the same as the Jacques Sadé, was delivered in September 2020. Maiden voyage, of course, was attended from our end, and we have seen that there are no major issues on the engine design as such. There were a few, let's say, challenges, vessel specific, also say partly related to quality, but on the design itself, we have not detected any, let's say, major flaws, which is of course very positive. The IGPR system is applied from beginning on these ships. It works very well, and also the WISE control system, our new engine control system, first time applied on a DF engine, and this proves to work surprisingly well, I must admit. So that was quite a relief for us, and this is also quite a positive sign for the other engines in the portfolio which will get the WISE control system. Now this is something about overhauling after 3 years in operation. In the second half of last year we had a chance to attend a major overhaul after roughly 3 years on the very first 62DF engine in operation, 21,000 running hours. We have seen piston running on this ship was excellent, with wear basically being 0 or close to 0. So theoretically, let's say endless lifetime if you want so. The gas admission valves, they proved to work very, very well. This is our own development, and the only, let's say, thing which had to be done there was lapping of the valve seats. So they will be ready now for the next 3 years now of operation. Also the pilot fuel injection system, another WinGD, let's say, specific with a pre-chamber technology, they do work very well. The wear rates, if any, are very, very low. So we see the potential, and we actually implemented already a first extension of the TBO time, and with a further growing running hours and experience, we will have surely the capability to extend those figures even further, which will of course directly result in a OPEX reduction for the operator. Main fuel injectors, there we have seen that those, even though they are not in operation, will need to have the regular maintenance, and that is because the main fuel injector nozzle tip is being exposed in gas combustion to the hot environment of the combustion environment, and this one leads to aging of the material. So those will need actually replacement every 8 to 12,000 hours, as we have stated in the manuals. A few words about service letters. A service letter, of course, this is always a chance to react quickly to something which is seen, to reach out to a huge fleet of customers, also then using the network from Wärtsilä to spread this word out and alert customers if something needs to, let's say, be looked at carefully. Maybe of interest here is the most upper one, the service letter 0015-1. This is already released since more than a year, but that one deals actually with the pre-chamber upgrades, which I mentioned earlier, which are relevant for the piston running. Then we have had an important update in August last year for control parameters on injection equipment, SL0025. The 0016 in September, this gives advice how an operator can run his engine if he's, let's say, disabling the ICAT system, so he wants to use only one cylinder oil, which is possible, let's say, for most applications and the low sulfur fuels which are in use nowadays. Service letter 004-2 from September. This is an upgrade giving the latest recommendations on the Checky cooling water system, on the mid-bore DF engines with the Uniflow and so forth. Finally, service letter 0027, which was released in February this year. That's about the potential cross-contamination of manifold injectors if old and newer parts are mixed, which can happen in the field. And the latest update on the lubricants was released in February 0018-1. This one gives an overview on the lubricants, namely cylinder lubrication and system oil for our not only XDF engines, but generally for the portfolio of WinGD engines. Summarizing the DF service experience as we have it today, with more than 1 million accumulated running hours. The engines are running well. The fleet is quickly increasing. We have new ship types delivered. We have new engine types entering service, which is very nice to see. We did have, of course, at the beginning and also throughout the journey, a few challenges, but they were tackled in a systematic manner and resolved. And of course, we keep monitoring closely the success and the behavior of the XDF engines in the fleet, in the sailing around the globe. A word here now about the support of the operating fleet, because that is, of course, very important. The customer not only wants to have a good engine, but he also wants to have the support if he's in need. And here we actually are working closely with our service partners. Of course, we do not have our own service organization, but Wärtsilä, with its global network, is a trusted partner when it's coming, let's say, for planning attendances, service support, operational support, whatsoever. But this is not only for, let's say, the hands-on job, the board attendances and the spare parts, but also a very important topic we have seen, especially now throughout the COVID situation, with limited traveling, the remote support. And Wärtsilä, with its remote support capabilities, the 24/7 support, and let's say their level of expertise, this has proven more than one time this to be very effective, helping customers in need, getting their ship, their engine back afloat and running, and we are very, very grateful for that. So in this respect, we do have a good cooperation between WinGD and Wärtsilä, and especially a learning out of the COVID times is remote support is important, and it can help tremendously a customer in need. On-time support, this is what counts. So, and now we move over to a few words about the future, our next generation. The new 72DF engine, it was announced also by a press release mid of February, and that's actually too much text here, I admit. Basically what we want to do is combine new features, new control system with meanwhile validated technologies from other engine types to bundle this into a nice and compact upgrade and fitting, let's say, the market needs of different engine types. Not only LNG carriers, where the 5-cylinder engine became quite popular, but also targeting other vessel segments for, let's say, to be powered by optimized XDF engines of the next generation. The new 72DF engine, called 1.1 or 1.2 respectively, then 2.1, 2.2 for ISR application, will be a drop-in solution, and it will fit into the existing ship designs. When we are looking here at the portfolio of the DF engine, on the right hand side we see in light gray the segment of the new engines, and of particular interest, and this is something which we did for the very first time, we introduced an engine with a relatively small rating field. This is the dark gray area, and that is the 0.2 versions of the 72DF, available as 5 and 6 cylinder only with a reduced power output. But this actually enables us to, say, optimize the engine design, the engine structure, to become lighter, to become more compact, and to implement also some other upgrades. And those are described here in this kind of table format. We do have the 1.1 engine on the left hand side as 5 to 8 cylinder, basically same rating area, rating field as the today's 72DF engine. But then on the right-hand side, we have the 1.2 engine. This is for 5 and 6 cylinder engine. That one will have a shortened bed plate. We have optimization on the structure, on main bearing yards. We have a shorter and lighter crankshaft. We of course have the voice control system on both engines, and we also apply a more compact supply knit, which was taken from the X62S short stroke engine, because for this smaller rating field, a more compact supply knit is sufficient, featuring also smaller fuel pumps, which should have, let's say, a better reliability and lower cost. And the same table we do have actually for the ICER engines, where the only change basically is that yes, the off-engine solution ICER is coming on top, but otherwise the engine structure and the optimization remains basically the same. So all these 4 engine types are now available, and we hope, of course, that there is a great future for them. Right, maybe this is okay. This is the last slide on the engine upgrade. Starting from top left, we do have the voice control system, as I mentioned. Then below, some weight optimization on the powertrain, crosshead, connecting rod, and so forth. This is under investigation. Looks very promising. We do have then the compact supply knit for the taken from the X62S engine. Bottom left, then the bed plate with a shortened thrust bearing section. This is applied as well. And when we move on to the right side, shorter crankshaft, the lighter crankshaft. The scavenging, of course, will need to be adapted to the ICER system as such. Then, of course, piping platforms, as usual, they need to be adopted. And finally, hot parts, because with ICER engines, we are running with a higher compression ratio. So to obtain the gains in fuel consumption, as outlined earlier by Carmelo. With this one, I'm at the end of my presentation. Thank you for your interest, and I'm heading back to Jeremy.
Thank you very much, Adrian. Super presentation. I was particularly impressed by the helpful and inspiring confidence from your real life operational experiences that you're able to share with us. I think also the COVID experience of the remote access really brings to life the value of that capability, not to mention the upgrades and future developments coming. But with that, I think it brings us to our next poll, in fact. So you know the drill now, audience. So if you'd kindly contemplate this question and answer to the best of your ability for your organization, this time you are asked to kindly please select your main business priorities. Choose the 2 most important to you from guaranteed asset availability, sustainable and predictable operations, fuel efficiency optimization, guaranteed maintenance cost, guidance, troubleshooting, tuning, and expert support. We'll give you a couple of moments to answer that poll. Super, I see the results are in already. Thank you again for making your selections. If I could on this occasion turn to you, Jürgen, to share your interpretation of these results for us.
Thank you very much, Jeremy, and welcome everybody. I find this very interesting to read. The sustainable and predictable operations is, I would say, by far the most critical one from business perspective. That's very good. And then we also saw it already from the presentation from Adrian, where the remote support and the guidance troubleshooting, especially during the COVID-19 situation, is highlighted here. Thank you very much.
Super, thank you, Jürgen. And if we can stay with you for the next presentation, I think you're going to present to us life cycle agreements. So Jürgen, the floor is yours.
Thank you, Jeremy, and welcome everybody. Yes, I will try to take you a little bit through what we are doing during the life cycle of the engines. But first of all, I would like to highlight one more time the cooperation between ourselves and WinGD, where we are the long-term service partner where we are servicing the WinGD engines, but of course also the Wärtsilä and Sulzer branded two-stroke diesel and gas engines. So it's really good to see this very close cooperation between these two very valuable and very big companies. So let's have a quick look at what is happening in the industry and what kind of pressure there is, because there is a lot of highlights, a lot of pressure where we are currently under, especially you as an owner, as an operator. We do see that there is a little bit of pickup again in the vessel contracting. We have seen recently earnings, especially on the bauxite, which have been going up a bit, or quite considerable actually. But utilization, fleet utilization over the whole industry, it is not fully there yet. There's still room for improvements. But when we look at those and we look at what kind of choices you have to make today, well, today's choices have a huge long-term impact. And we have already seen before in the first poll where we were asking for what kind of fuels are you looking at, and what kind of focus we should be having there. And it is very clear that there is a need for flexibility on fuels, LNGs, methanes, etc. But it also means the complexity is increasing. So that is something which has a direct effect on how do you operate the installations. Then we are very much following, of course, what is happening on the environment, what's the compliance there, the decarbonization. We need to find also ways on how do we deal with the greenhouse gases and what are the targets there further. So what we have observed from our side is that the shipping companies, you as a customer, challenges are very, very specific, but they're also very business driven. It has to be profitable. And how do you ensure that? You need to adapt to the new technologies and you need to be compliant with environmental regulations. But how do you deal with those and how to ensure this for a longer period than just today? That is an area where we would like to go through today a bit. And we think we have the solutions for you. We think we can support you. We think we can support you to improve your business. We think we can have an impact on your earnings. We can have an impact on your costs by these long-term service agreements. So how do we do that? Well, first of all, our target is absolutely there to make sure that you as a customer are able to achieve the targets you have set yourself in respect of earnings. But also we also are thinking that, or are convinced actually, that we can improve that even further. To give you an idea, our expertise centers, they have resolved 90% of all the customer cases by remote support. And 80% of all those cases, they were resolved within the same day. So faster resolving and decreasing is one of the items where we are absolutely focusing on. Another portion is how do we ensure that the profitability is there? How do we ensure that or even increase the profitability? Well, we could be thinking about to make sure that if there are long-term improvements in the maintenance, to make sure that we are implementing those if and when they are happening, and that directly benefits you as a customer without losing any reliability, any availability of the equipment. For instance, when we are looking at the predictability of the operations, when we are applying expert insight, we know that we can reduce up to 70% of the unscheduled maintenance. And this is not just information, this is actually from our installations which we have under our contract. This is coming from 54 LNG carriers which we are having under contract. So who are we? Well, we currently are having well over 700 installations under agreements, long-term agreements. We are just to talk a little bit about what is the customer saying, and when we are coming from the customer, and one of them from container ships, for them it is, because it's a single engine operation, it is absolutely vital for them that the engine is operational, available at all the time. On top of that, they find it crucial to have a 24/7 contact number, access to our technical support. And the customer clearly makes a statement very clearly is that Wärtsilä takes responsibility. We make sure that the overhauls are being carried out as in cooperation with the operator, to make sure that there is no influence on the maintenance, on the operational availability. So how do we do it? Well, one of them is asset performance, what we would like to call, where it is absolutely looking at a little bit of a holistic view, where we are looking at optimizing the maintenance, optimizing and basically guaranteeing certain performance parameters. Another way to look at it is much more, let's call it traditional. It's about the traditional maintenance agreement. It's really focusing on a portion of it. It's the maintenance where we are then putting the most emphasis on. And that's what we call Wärtsilä optimized maintenance. This allows you to have a very clear indication of how much maintenance is needed, what it will cost, and it will give you full financial predictability. So when we then think about what is the effect of this in money-wise, what does it mean in a real case? Well, I mentioned it before already, and when we take these 54 installations, which are under our care, which are monitored very closely by us, we have been able to reduce, or actually to avoid and respond in 90% of all the cases to the requests from the customers. And there were in total 1,100 requests for support. If we would take these as, let's say, 80,000 euros per day charter rate, multiplied by the 1,100, and we have a 90% resolution online by directly remote support, 24/7, it means there is avoidance of 8.8 million in revenue. We are not, or you as a customer are not losing this money. You are able to keep operating and perform as your customers are expecting from you. Then when we are looking at the unscheduled section, and we mentioned it already before with the expert insight, we are able to reduce these costs. And when we really look at it, and again, out of the same fleet and the data we have, by preventing and by identifying problems early enough, we are able to reduce by 70% the maintenance cost, the unscheduled maintenance cost. Looking at a whole fleet of 54 installations, that means we have saved you, your customers, 3.8 million euros on unscheduled maintenance. So what else is there? Well, by having this kind of proactive and early detection, we are able to also reduce the duration. With duration, it means that every time when a customer is calling and there is an issue, when we are looking at it, we had in 2019 maybe up to 3 days. Currently, we know that within whatever we are, or within the Expert Insight and the remote support, we are able to reduce this by 50%. So we are on average at 1.5 days. And this again means another 6.5 million revenue, which is being saved, which you're not losing because of hire. It's not only the LNG vessels, it's not only one specific section, one specific sector, but we have a very, very wide. We are looking at merchant, where we have the LNG carriers, where we have the container vessels, the cruise and ferries we are having covered. We are having offshore vessels as well as special installations. Very wide installed base and well over 700 marine installations where we are having a Wärtsilä lifecycle solution. So what does the customer say? What does our customer state about how we are performing? And Gaslok has given us a very good feedback, and they had a challenge because they would really need to ensure the fleet operations, and they would really like to free up time spent by their staff, and really be able with their staff to focus on their core business. And that is not the maintenance planning, that is not the finding out which is the right moment to do which maintenance. So we take care of that. And as a result, the customer is reducing its maintenance costs, has full predictability, has availability of spare parts and technical personnel, and basically his people, his staff can concentrate on the core business activities. Not only one, we have a lot of customers who are very positive about speaking about us. And another one would be OSM Ship Management in Finland, where they require top performance and economy of each engine. They would like basically to eliminate all unplanned servicing and maintenance. On the same time, they also would like to lower the overall maintenance costs and have visibility on the long-term planning of maintenance activities. So there we have agreed on a long-term service agreement, as well as how are we jointly working to optimize the performance and how can we have the on-time maintenance done. So the customer is there absolutely benefiting from maximum uptime, has a clear view on what he's going to spend, and thus also he knows his profits are basically secured. And we have at all times an optimum engine performance and the best fuel economy. So that would it be from my side, and I would like to hand back for the Q&A session to Jeremy Cross. Jeremy, please.
Thank you very much, Jürgen. I think an ultimate aim is to make customers more competitive in their businesses, and you showed very clearly how you do it, increasing customers' profitability and mitigating customers' risks. And as examples, I think very nice, thank you. But as you say, it is time already for our questions and answers. Thank you to the audience members who've already submitted questions. So if I could, yes, indeed, ask the colleagues to open their cameras. Our first question, I think it goes to you, Carmelo. So if I may, Carmelo, have you tested ISA and what are the results?
Sure, we tested actually we did a intensive campaign of testing and validation for both either gas and diesel mode. The result is actually we had also a demo for the either in gas mode last year. So the result is what we announced, what we guarantee actually to our customer in the term of the gas consumption, and we announced 3% less. Even at some point we achieved something a little bit higher in terms of reduction, and in diesel mode 5% reduction. And also we concluded this year in February the diesel mode. So we achieved tier 3 in diesel mode with the same ISER technology. Just we added some change on the engine, on the cooler and some other part, and the water treatment system. So the test is really completed. So we are now in the commercialization phase.
Super, thank you, Carmelo. If I may stay with you for maybe the next couple of questions. Also, the next one is related to ISER, and the question reads: is ISER available for retrofit DF engine?
Yes, it's available for retrofit, but what we have learned in the last couple of months is a little bit need the involvement of the shipyard, need the involvement, need some change. So this should be done, but it is a retrofit that need to be studied together with the shipyard. From WinGD point of view, we always support the customer with information, with the interface, and helping to find a solution. So.
Okay, thank you very much.
Yes.
Super, thank you again. And I think this question perhaps also goes to you, but help me redirect it if necessary. Where does come from PM emission for these gas engines?
That's a very good question. The PM emission theoretically should be 0. We have a little bit of PM emission because of the combustion of the cylinder lube oil. And this in gas mode we are talking about. And then because the Otto cycle has theoretically very, very low PM emission, but still one part of the lube oil that is very low because it's 0.6 gram kilowatt hour, half of them will get burned. And this part causes the slow amount of PM emission.
Okay, thank you. Thank you, Carmelo. If I may now turn over to Adrian, I think the next couple of questions perhaps come in your direction. Adrian, after 10 years of the engine's launch, what's your experience in relation to the reliability of the X72DF engines?
That's an interesting question. I would state that the 72DF engines, they have been performing very, very well overall. I mentioned earlier that we faced some challenges back in second half of 2019 and early 2020 with piston running. On a few, let's say very few vessels, 3-4 ships were affected by then. These issues were resolved, but outside of that, in fact, we have not discovered, let's say, major issues. So overall, I would say for that it was a relatively new technology. It behaved very, very well.
Thank you, Adrian. Sticking with you, if I may.
The 72DF has not been in operation for 10 years. And the first delivery was in January 18.
Okay, thank you for that clarification. Super, thank you. But sticking with you, if I may, you mentioned a little bit about the reduction in engine's weight. Does that bring any technical risks or side effects?
None whatsoever. I mean, a weight reduction, of course, you need to say, be careful where you save weight, and in our approach, we actually apply a design which was validated now on the 92DF engine and the X92B type engines, weight reduction in form of structure optimization on the main bearing girder. So to reduce the edge load on the main bearing shells, this is one part of the weight reduction. So by changing, say, the geometry of the main bearing girder slightly. And the other part is by optimization, shortening of the thrust bearing section, the end part of the engine. With the new supply unit we apply there, you can actually shorten this one quite significantly. And we have actually on the bed plate alone savings of 4 tons in this area. So this, however, has no impact at all on the, let's say, on the reliability or safety.
Good to know, thank you. I think this this is an acronym question, perhaps also to you. What is IGPR?
Okay. Apologies. This is maybe a term which is not so commonly used, not yet. Let's say fuel gas supply system for controlling the gas pressure traditionally used to be the Wärtsilä GVU gas valve unit installed shipside. But some years back, WinGD decided to integrate this solution onto the engine platform itself, which would be, let's say, especially for smaller ships benefit. You need less room in the engine, less space in the engine room, and this IGPR stands for Integrated Gas Pressure Regulation. So the function of the Wärtsilä GVU would actually move onto the engine in form of this IGPR, Integrated Gas Pressure Regulation. That is the full name of it.
Thank you very much. Thank you. Turning now to Jürgen, if I may. Jürgen, question for you. Is Wärtsilä prepared to provide guarantees under the presented agreements, for example, uptime, fuel efficiency, or other guarantees?
Thank you, Jeremy, and it is a very big, challenging question. But from our side, we are convinced that if you can measure it, you can guarantee it. So as such, yes, we guarantee everything, basically almost everything we can measure, we would also be able to guarantee. But we do also should have a look at what does it actually bring to the customer. If it doesn't bring any value to the customer, if it doesn't bring any benefits to the customer, if it doesn't secure his risks and mitigate his risks, it has no effect whatsoever, and it makes not much sense in that respect. So yes, we are guaranteeing this, but it also means we need to reflect on what makes sense for the customer.
Okay, and a follow-on question to that, I think you've partly answered it already, but it's how could you achieve what you're promising?
Thank you. Yes. So how do we achieve it? We achieve it by certain measurements, by implementation of certain processes, follow-ups, and by defining very early in the various discussions on what do we want to achieve with a certain long-term service agreement, and then how do we define the guarantees, and how do we define what needs to be guaranteed.
Super. Thank you, Jürgen. Conscious of the time, one other question came in about the presentation slides, and I can confirm for you that the slides will be made available for you all outside of here. I think we do have time for maybe one or two more questions. Maybe to you, Adrian, if I can turn back to you. Question reads, many engines are facing fuel pump trouble, especially breaking of compression spring. What is the solution for this? New type of springs are available?
Yes, this is a topic which, let's say, was known or was first occurring on the diesel type engines, in particular on the large bore. And we released a new design, a higher grade of the spring material sometime last year. There is also certain stock of these springs available, and let's say after implementation, following also field test results, this issue seems to be very much resolved in general, let's say. We have one particular ship where there were some further challenges, let's say also with the new spring material. This is, let's say, under investigation, but we were, let's say, capable of advising the customer to cut out one fuel pump, which is possible on this 6-cylinder engine. And since then, this took place in February, as I remember. There were no, let's say, new damages reported.
Thank you, Adrian. I think hopefully this is a quick question, so I will take this one. Do you provide platform in the future, such as WhatsApp, for quick support from Wärtsilä?
Thank you, Jeremy. If I'm allowed to answer. Yes, please. We have already a platform. It's not a WhatsApp, but we have a platform for all our customers, and it is an online tool which is basically bringing our customers in directly contact with the various specialists on the background who are answering their questions. It's in our online portal, and I would say that if you as a customer do not have access, then please do request this, because we have possibilities there. Yes.
Thank you very much, Jürgen. Now, apologies, folks, to those of you who have raised another question. We have reached the time limit of this webinar, but we will follow up answers to those unanswered questions outside of here. So with that, I do need to draw this webinar to a close. I would like to thank our subject matter expert speakers for their super presentations and for fielding such good questions with their equally good answers. So thanks to our speakers for sharing also their insights with us. Most of all, I would like to thank you, the audience, for taking your valuable time to join us here today. On leaving the webinar, you will see a short exit survey. It comprises just 2 questions, so please take a moment to help us by answering those questions improve our future deliveries. The questions are simply, did this webinar meet your expectations? And what changes would you make to the webinar? So thank you once again from all of us, and goodbye. Goodbye.